Welcome back. We're going to take up, we're in the middle of 3 sections on hay production. This is section 2, and we're going to talk about equipment. And that will primarily be mowers, the tedders and rakes, and the balers. So let's start talking about the types of mowers that we will find or that are used. Now, when I had my first job at 50 cents an hour, true story, this is the kind of mower that we had. We had a sickle bar mower. And if you look at it's quite a simple machine. It's very cheap compared to other things that you might buy. And it's called a sickle bar. This is the sickle and a sickle bar right here. It's got a bunch of these teeth that are laid on top of this, or it actually slides back and forth in these guards, and it catches the forage between these moving teeth and the guards, and that's how it cuts the forage. The most common type of mower is going to be a disc mower. And a disc mower, as the name suggests, is going to have discs. And here's a series of them. You can see them in a line in still a relatively simple piece of machinery. And these spin with these very short blades on them, and they overlap, and they do a quite effective job of cutting forage. A type of disc mower is called a mower conditioner. The next type I want to talk about is called a mower conditioner. Conditioning mowers are disc mowers, or I guess you could have a sickle mower as well, attached to with a conditioning implement or oops, my bad. But anyway, you have a mower with, in this case, this photo has got intermeshing rolls. So here are your rotating discs, your disc mower with this is the conditioning rollers here. These are intermeshing rubber rollers. They have ridges that are offset so that the crop as it's cut is pulled between these rubber rollers, crushed and crimped, making extra openings in the stem in particular for water to leave. So the conditioning mowers crush or crimp stems in particular, and it speeds up the drying of those stems of legumes and also thick-stemmed summer annual crops. Another type of mower conditioner are the impellers. Of course, this has got both of them side by side. On the left is the flail type of impeller, and on the right are the crimper roller types or intermeshing rollers. We typically would rather use the intermeshing roller types because it's more gentle on the crop. This actually is quite aggressive in how it conditions, and it's been proven in research that it's more likely to knock leaves off of legumes. However, it is very effective at scratching up the stems of thick-stemmed grasses like summer annuals. And until the last couple of years, I would have said we almost never see any of the flail type impeller conditioners, but yet in some places in Kentucky, this is the better selling model. And you can see that it would be simpler to maintain. It would be much less likely to clog with the impeller than it does with the intermeshing rollers. So let's do a quick comparison. I didn't show you a picture, but there's a fourth type of mower on here called down here in the right or lower right called the self-propelled mower. So we've got the sickle bar mower. It's slower at how much forage you can move across it or get through in a day. There's more maintenance, and that you might want to put an asterisk by that, but that trying to keep those the sickle blades sharp, those little blade pieces sharp, and because it is prone to knocking those off if you hit a rock or something with those. But they're also vastly cheaper. These are almost never seen anymore because they've been replaced by the disc mowers because they're faster, they cut tougher crops. They have a simpler mechanism in that those blades are short, they are very tough, and for the most part, almost never have a problem. Now, put an asterisk there. It's not simple if you've got to take one of those apart and fix one of those drums in that long line of drum mechanisms that are spinning. It's more expensive than a sickle, but less than a mower conditioner. and we abbreviate mower conditioner MOCO. And this is, as I said, the most common type. Mower conditioners, more expensive, can put forage in a swath or leave it wide, and it does that by using baffles back behind those intermeshing rollers usually. They can plug, and that would be the intermeshing roller types. If you get a real big wad of forage crops, they can and sometimes jam. They are better to cure legumes because they crimp stems, and better to cure summer annuals, the stems of summer annuals. The impeller types are abrasive and we get more leaf loss. The self-propelled mowers are much faster. The wheels actually will straddle the windrows or the swath, so you don't have that mashing down of that forage, which slows drying. And of course, they are more expensive yet. So let's talk about, once we've got the forage laid down, let's talk about what we might do to manipulate it. Now, we've talked, at least briefly, or mentioned an implement called a tedder. And a tedder is a very simple instrument that rotates. It has rotating prongs that you run along on a crop, and it throws the crop into the air, and it winds up with having sometimes inverting the windrow, putting the dry stuff up on the top, and all the time it will typically make the forage to be fluffier. So you've changed the architecture of the windrow so that it will then catch more air, and you might have moved the wet to the top so that it can dry faster. It can increase, running a tedder can increase leaf loss and legumes if it's done when the crop is really, really dry. So you want to be careful how you do it on legume crops. And some people swear by them. Some people say that, that make good alfalfa hay. Never use a tedder at all. So this is a personal preference, although it is absolutely true that it will help fluff up and speed up the drying of a crop. Here is the next step that we would do after you've tedded and you're getting close to moisture content for baling. And we might use a wheel rake. That's the top rake. And it gets its name quite obviously from these large wheels. It has the advantage, or a lot of people use it because of capacity. Look at the space that you can cover when you rake. So it covers a lot of ground. It has to be driven by the crop itself or by actually touching the ground. Then these tines have got to be fairly low down, and that's how you have to adjust this so that they're just barely touching the top probably of the forage, and trying not to touch the ground, because it can pick up more dirt, and it will pick up more dirt than the alternative, which is a bar rake like this. We sometimes called a basket rake or a rotating bar rake. These have these vertical tines that come down, and they move in a circular pattern, and then move the hay over and concentrate it up into a windrow. These are driven by the wheels, these drive wheels here in the back. They are slower. You can actually have two of these hooked together and cover more ground, but this is just a one unit rake. They slower in terms of how much crop it can do at one time. It can float over the ground, so you don't have to have it. It's not as aggressive. You can adjust it so that it's not get down into the soil as much, but it will have trouble when you have very heavy crops. But if you have a very heavy crop, then it's going to be hard for any rake or most rakes to handle them completely well all of the time. So let's talk about balers. And I realized I don't have a picture of a small square baler here, but we've seen one earlier in the lecture. And the point I want to make about balers, of course, we can have the small squares, we can have the medium-sized rectangular bales. You've got, in this case, this is one of the 4x4x8s in the upper right, and you've got our traditional round bale here on the left. The balers, the bigger the bale, then the drier the hay. So we've made this point before. The small square bales need to be 18 to 22%, somewhere in that range. The round bales 15 to 18. The large squares less than 16% at baling. Talk a little bit about hay preservatives. hay preservatives are materials that are applied at baling to hay that is just above at slightly elevated moisture contents, 22% up to about 30, although most when we want to avoid trying to make this kind of material into hay, but we put hay preservatives on at these elevated moisture contents to prevent heating and molding. The acid products are the most effective. Pardon me, I've left off the rest of that word. And the acid that is most often used is propionic acid. A lot of times it's buffered, so it's not as corrosive to your skin or to the equipment as the original hay preservatives were, which were almost completely acid and not buffered at all. The moisture content sensor in the balers in an operation like this made by Harvest Tech allows constant adjustment of the spray rate. The rate that is applied to the hay as it's going into the baler here is moisture dependent. So you've got sensors back here on the baler wall that as the bale is being formed, you get a sense of how wet the crop is. And the wetter that sensor indicates, then the more product that is sprayed out here. Obviously, there's a little delay. You got to get wet hay in here before you get an increase in rate here at the sprayer. But yet it's certainly more effective than just taking one moisture reading before you start baling and then applying it, but due to that moisture reading for the rest of the day. I want to talk about the string versus net wrap versus another material called B wrap. So once we have a hay bale, we've got depending on your preference, you may wrap it with string, you may wrap it with a product called net wrap, or you may wrap it with something that's one of the newest products called Breathable wrap or B wrap. So the string is the most traditional. It may be sisal twine, which is a native or it's a natural fiber, and usually it's treated or oiled. Then you may have plastic string. This is cheaper, but as an operation, it's slower for making when you have round bales and you're waiting to at that very last stage, you've got the bale made and you need to wrap string around it. It's slower, just a little bit, than net wrapping. And it provides almost no weather protection compared to the other two. Net wrap is faster to cover the bale and it does shed some water. It is more expensive than using string, but there's more waste and more trouble than when you're trying to feed it. You've got to get all of that net wrap off. The last thing I want to talk about is a product that we haven't seen very much of, to my knowledge, in Kentucky, and it's called the B wrap or breathable wrap. B wrap allows water vapor to leave the bale, but rain doesn't penetrate. It's been measured in research to be equivalent to indoor storage, and it is even more expensive than net wrap. Here is a little bit of information about the B wrap. One company that makes it is Ambraco in Dubuque, Iowa. Again, sheds water, but lets moisture out of the bale. The cost is about $5 over net wrap. And John Deere is the implement that has this option, and there probably will be others. Just a little bit of information on the B wrap versus other versus net wrap inside and outside. There are 4 different trials, and you can see that the blue is the B wrap outside, the orange is net wrap outside, and the gray is net wrap inside. And this is the dry matter loss. So B wrap outside is going to have, in this case, in this study, had slightly less dry matter loss than net wrap inside. The net wrap outside had about 12% or 11% loss here, 12 and 12 in the other two studies. So you can see that the B wrap outside is equivalent to the net wrap inside. This is after 325 days in storage, alfalfa round bales. And one last piece of equipment or type of equipment that we'll talk about are called the Bale Accumulators. These are to save labor. On the upper left is a bale accumulator, self-propelled bale accumulator. You pick it up in the field and it forms stacks that can then be left in the field and then moved into hay barns. And on the right is what is known as a bale grapple, where you can, it's accompanied by something that's pulled behind the small square baler that lays out the bales in, say, about a 4x6 or about a 4x2 pattern or 4x3 pattern, and in the field. So it will then drop those off. You would then come behind with this grapple and pick those up and these hooks would rotate down into those square bales, pick them up, and you would and then move it onto a hay wagon and move it to storage. So that ends our section on hay equipment. And when we get together again, we'll finish this three-part series by talking about hay storage and feeding.